In this video, we're going to talk about indices and surds, and we'll be solving 3 questions from past paper together, and these questions are very common in our papers. But before starting, we need to know some rules first. Okay, and the first one is a to the n over m. It is equals to a to the m and to the nth root of it. The second one is when a and b are in a pair of parentheses, and the pair of parentheses is raised to a power of n, and the n outside will multiply with the exponent of a and b. So this will become a to the n and b to the n. And the third one is when a to the n multiply a to the m. When we see multiplication, the exponents will add together, so it will become a to the n plus m. And the fourth one, it is the opposite of the third one. When a to the n is over a to the m, this is equals to a to the n minus m. But that's the opposite operation of the above one. With these 4 rules, we can start working on the questions. Okay. So this question is from the paper in 2022. Our final answer should match this part, where P, Q, and R only has 1 exponent each. So our first approach will be simplifying all the square roots of the parentheses into a base and an index. Okay. First, when we see the square root of P, we can think of it as P to the 1/2, because the 2 here is actually the second root of P. So this will become P raised to 1/2 times Q to the 2/3 times R to the -3, and this is O over the 2 has to distribute into both of this number. This will become P to the 2 and R to the -2, because it is multiplying with -1, and this multiply with R to the -1. Now we need to apply the fourth rule, because we're saying the same base and they are in fraction. So the first one, the P term, it will be 1/2 from the top minus the 2 from the bottom, because it's a fraction. Then this will multiply R to the power of 2 over 3 minus -2. This is a tricky part, because the operation is still subtraction, but you are subtracting a negative number which will later become positive. And multiply R -3 minus -1, and the same. This is tricky. And our final answer is 1/2 minus 2. It is -3 over 2 times Q to 2 over 3 minus -2 will become 8 over 3. Then times R to the -3 minus -1, it will become -2. So here we get our ABC value. It says find the constants, so we'll put down their individual value. It will become A equals to -3 over 2, and B is 8 over 3, and C is -2. So this is our final answer. In the second question, we need some more rules. The fifth is when a to the n is raised to a power of m, and then the two exponents will multiply. Now it will become a to the n times n. Number 6, it will be the root of a times the root of b, and the values inside will multiply. It will become the root of ab. Now we can start working on the question. In this question, we are seeing a quadratic equation. In this question, it is asking for intersections. Whenever we see intersections, it means they share the same x and y value. And in this case, we can see the y values are isolated. So we can simply join the two equations together by substituting y. It will become x squared plus 2 times root 5 x minus 20 equals to the second equation. It is 3 times root 5 x plus 10. Now we will move all the terms to one side because we're seeing a quadratic equation, and we need to make one side 0 so we can solve the equation by using the quadratic formula. First, the other side has no square term, so the coefficient is still the same. And now we'll just simply put down this term. Then we'll minus the x term from the other side. We'll put down minus 20 and move the plus 10 to this side. And here the right hand side becomes 0. Now we'll simplify the equation. So the x squared term is still the same. And here we can think of this term as 2 times root 5 minus 3 times root 5, and this is the coefficient of x. This will make our calculation easier, and the constant term is pretty simple. Minus 20 minus 10, it will become minus 30. And now the number between, we can just simply subtract. You can think of it as 2 minus 3 because we're seeing the same surds. It is both root 5. It will become minus 1 root 5, but we don't need 1. It will just become minus. So you can get rid of the parentheses and get rid of the plus sign. Good. Now this is the equation we are having. Okay. And now we need to apply the quadratic formula to solve the equation. In case you haven't memorized it, this is x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Although you don't have to memorize, but you are recommended to, because it will help you with your calculation speed. Alright, so the negative b term, it will become the opposite of negative root 5, so it is positive root 5 plus or minus square root of negative root 5 squared. It will become positive 5 minus 4 times the a term is 1 times minus 30. Then this is O over 2a. The a here is 1, so it is O over 2. But after simplifying the part here, we can find the number in the square root. It is 125. So this is root 5 plus or minus the square root of 125 all over 2. You might have noticed that 122 is actually a multiple of 5. And now we can even simplify the 125 into 25 times 5 in square root by applying rule 6, and 25 is a complete square of 5, so it can be simplified to 5 and still all over 2. Now we'll have two solutions because we're performing both plus and minus. The first one is root 5 plus 5 times root 5 all over 2. The second one, it is root 5 minus 5 times root 5 all over 2. And the first one, it is 6 times root 5 over 2, which is 3 root 5. And the second one, it will be negative 4 root 5 all over 2. It will be negative times root 5. Okay. These are the answer, but they are the x components of the two coordinates. And now we need to plug in these values back to our original equation so we can know the y value of these coordinates. To me, I find using the second equation, it will be easier for calculation because we don't need to square it. The first y value, so first we'll put down the 3 times root 5 here, and we'll put down our first x value, it is 3 root 5, the same. Then plus 10, and this is 55. The second y coordinate, it will be 3 times root 5 times the second x value, this is negative 2, times root 5 plus 10, and this is negative 20. So here we have our 4 solutions. In the last question, we need to solve this quadratic equation, and the solutions have to be in the form of a plus b root of 3. So let's then we'll apply the quadratic formula, and the first term will be the opposite of b, which will be negative 2 root 3 plus 5. And be careful of the parentheses, it has to be there because the negative outside will distribute inside. Then we'll put down plus minus and the square root of b squared 2 root 3 plus 5 parentheses squared minus 4 3 minus 5 root of 3, then negative 1 in a square root, and this will be O over 2a, which is 2 parentheses 3 minus 5 root of 3. First, we can see that in the discriminant we have 2 negative signs, and in fact these 2 negative signs can directly multiply and become positive. This will simplify our calculation. Then we'll put down the opposite of b term. We can distribute the negative into 2 terms. Then we need to simplify the discriminant. We can apply the binomial expansion rule. A plus b squared, it is a squared plus 2ab plus b squared. The a here is 2 root 3, so the square of it is 4 times 3. Then 2ab will be plus 20 root of 3. Then square of 5 is 25. Then we'll distribute 4 into the parentheses. It will be plus 12, then minus 20 root 3. And these are in a square root. At the bottom, we can distribute 2 into the two terms. Right now in the discriminant, we can see there's a positive 20 root 3 and a negative 20 root 3. These two terms can cancel. Now we only have integers in the square root, which will make our calculation a lot easier. Now 4 times 3 is 12. 12 plus 25 plus 12, it will be 49. And the square root of 49 is 7. The expression here is in fact our solution, but it is irrational. We need to rationalize it. And the question requires the form in a plus b root of 3. Now we'll proceed with our solution and simplify it into the required form. The plus version of it will be negative 2 root of 3 minus 5 plus 7 all over 6 minus 10 root 3. And the minus 5 plus 7 here can be simplified into plus 2. Now we need to perform the action called rationalization. It is when C is the denominator A and B are in the bottom, and we want to multiply with a negative sign in between, so the irrational part of this fraction will be eliminated. So in this case, we'll change the sign of our denominator, so it will become 6 plus 10 root of 3, and the same for the denominator. Now we'll distribute all the terms. On the top, we will do this 2 first. It will be negative 12 root 3. And then we will plus the product of negative 2 root 3 and 10 root 3. In this case, we can actually rewrite the order. We can let it become negative 2 times 10 times root of 3 times root of 3. 2 root 3 times together, it will become a 3, and these 3 integers times together, it will become negative 60. So this term will just become minus 60. Then the next part, it will be these 2 multiplying together. We will have plus 12 and plus 20 root 3. For the denominator, we will use another binomial expansion identity. It is a minus b times a plus b. It is a squared minus b squared. The a here is 6, so a squared will become 36. And the b here is 10 root 3. The square of it will become 100 times 3. And the operation is minus. This will become 300. If we further simplify it, we can collect like term. For the integer part, negative 60 plus 12 will become negative 48. And for 2 root 3, it will become plus 8 root 3. Negative 12 plus 20 is plus 8. And this is all over negative 264. Now we can divide each term individually. Negative 48 divided by negative 264 will become positive 2 over 11. And this term will plus 8 root 3 divided by negative 264, it will become negative root 3 over 33. And this is our first solution. Now we'll work on the second solution, which is a minus version of it. There'll be minus 7 here. The minus 5 minus 7 can be simplified to minus 12. And the same, we'll perform the rationalization process. We'll change the sign of the denominator and multiply it with both the numerator and denominator. Now we need to distribute. Our denominator will be the same as our solution above. We'll first distribute these two terms. The first will be negative 12 root 3, then negative 2 times 10 times root 3 times root 3. The first two integers will be 20, and the two roots 3 multiplying together will give us 3. So this term will be negative 60. We'll then distribute these two terms. The first will be negative 72. Then the second one will be negative 120 root 3. We'll now collect like term. For the integer part, negative 60 minus 72 will be negative 132. Negative 12 root 3 minus 120 root 3 will be minus 132 root 3. All over negative 264. By dividing the two terms in the denominator individually, we'll get positive 1/2 from negative 132 divided by negative 264. Then plus root 3 over 2 from negative 132 root 3 divided by negative 264. This is our second solution.